Well, welcome back. We've been working a lot with our sums and our differences, right? Remembering this idea that a sum, wow, is the answer to an addition problem. Holy, let's fix that. That just looks sloppy. A sum is the answer to an addition problem, and that a difference is the answer to a subtraction problem, right? It's this idea. And again, there's a relationship between these two. We call that the inverse, right? The inverse operation. And if you just think about that real quick, that would be that same concept that, let's say we have 5 plus 3 equals 8, right? And if we took the inverse, that would mean that 8 minus 3 equals 5, right? It's this idea that things go back and forth. So we've been talking a lot about these sums and these differences. We talked about sums and how we can model them, and also how we can use an algorithm. We have also talked about modeling the differences that we've been working on. And so today we're just going to dive in and relate how to do that as an algorithm, which really is the exact same thing. It's just about like how you model it. It's the same process. So don't be too stressed about that. And again, I will try like I did. Let's see, let's just do a problem first. I'll try like I did before with the idea of showing both in the beginning so we can see those relationships. So I'm actually going to do this, and we will model on this side, and we will algorithm on this side. So first things first, if we were going to model, again with subtraction, I have my hundreds, my tens, and my ones, and we only model the largest number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3. Okay, so we'll stop there. We'll come over here for an algorithm. We'll set up our problem. Okay, and again, just to keep in mind, you don't have to do this when you do an algorithm, but if you want to think about this, right? Here's my ones place. It's almost like that model is there. It's just that instead of showing it in base 10, I'm just putting the numerals in there. I'm putting the digits in there. I'm just placing them in, and we go ahead and do that work. So with both of these, as always, where do we start? We always start in the ones place, right? So if I just start over here in my ones place, I'm just looking at 9, and I'm going to take 3 away. Well, if I have 9 and I take 3, use any strategy. You could count up, subtract. That's 6. We're going to do the same thing over here. We're going to start in our ones place, and we're going to take 3 away. 1, 2, 3. Then we'll count 1, 2, 3, 4, 5, 6. What do you know? There we go. We can see the connection. Okay. Same concept here. I'm in my tens place. So I'm going to take 8 tens, and I'm going to subtract 6 tens from that, which I can do. If I have 8 things, I can take 6 away. It leaves me with 2. Let's look over here. Same idea. I'm going to take 6 away. 1, 2, 3, 4, 5, 6. So I got 2 left. Great. Hundreds place, I have 3, and I'm going to subtract 1, which leaves me with 2. And I come over here, and I have 1 that I need to take away. It leaves me with 2. And as you can see, we got the exact same difference, right? So here's with our model, here's with our algorithm. Now that moved really smoothly because the reality is in this problem, it's one problem. In this problem, we did not have to decompose. So of course now, let's kind of look at what happens if we do have to decompose. So I say 1,582. And let's take away what am I doing? Let's take away 973. Yeah, let's do that. Okay, so can I save this? 1,582 minus 973. All right, so this will be my model over here. Again, we'll kind of go along with it. And here we'll use our algorithm. All right, so set things up and line up your place values correctly. Notice again, here's a thousands place, but there's no thousands place here. I'm putting my hundreds with my hundreds, my tens with my tens, and my ones with my ones. Always line up your place values, otherwise you're going to run into some troubles. Here, we are going to create our model. We have our ones, our tens, our hundreds, and our thousands. Only model the largest number in subtraction, right? Always just the largest number. With addition, we put them both into the model, but again, with differences, we only model the largest. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, and there. All right, so let's just kind of dive in. So algorithm again, we're going to come over here, and I'm going to start. I have 2. I need to take 3 away. Well, if I have 2 of something, I cannot take 3 away, right? If the bottom number is bigger, then you go ahead and decompose. So we're going to go over here and decompose. So if I take 1 10 away, I now have 7 10s. And that 10 I took, I broke into 10 ones, which means if I bring those over, I had 2 ones already, plus 10 more, I'm going to have 12 over here now. So let's look about what that would look like over here. Again, take 3 away. I can't. So decompose. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, you can see in my ones place, I now have 10 items and only 1, 2, 3, 4, 5, 6, 7 tens left, which is what is said over here, right? There's that relationship. So 12 minus 3 is going to equal 9. And let's, if we do that work over here, let's take our 3 away and then count 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. Okay, now in our tens place, I have 7 left and I'm taking 7 away. So 7 subtract 7, that'll give me 0. Let's do the same thing here. I got to take 7 away. 1, 2, 3, 4, 5, 6, 7, get me 0. Okay, I hope you're seeing the connection between these two, because if you have a good understanding of the model, then you can use a more efficient way. Like that's what we say a lot, an efficient way of using an algorithm. But it doesn't matter. Like you use the one that's most comfortable with you, for real. Like use the one that works best. There's no rules. You just, as long as you get to the end answer, we're good. All right, hundreds place. I have 5 and I'm taking 9 away. Well, I cannot do that because I have 5, right? What you on top is what you have. So we're going to decompose this 1,000, leaving me with 0 thousands. And that means I have 10 that I'm adding to the 5 I already have. So this is now a 15. So 15 minus 5 would give me 6. And then I have a 0 here. So it looks like I have 609. Let's go over and see what happens with the model. Gotta take 9 away. As you can see, I cannot. So decompose. This means I get 10 over here. Oh, I'm gonna have to squeeze these in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, they're all in there. We see them. Good thing I changed colors. And now we need to take 9 of them away, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6 are left. So there you have it. We did it again. This is 609. This is 609 using an algorithm. Okay, so we're going to do another one real quick, and we're just going to do the algorithm. So I'm going to go large. And we're going to subtract 68,532. Okay, so let's walk through this as an algorithm. Always start in your ones place, right? We're always in our ones place. I have 7, I'm taking 2 away. I can do that, right? 7 minus 2 will give me 5. Okay, tens place. Well, I have 1, but I'm supposed to take away 3. So I cannot do that. That does not work, right? When the bottom number is larger, that's when you have to go decompose. So we're going to take 1 of these hundreds away, leaving me with 7 hundreds. And that's adding 10 to the 1 I already have. So that's 11. So 11 minus 3 will give me 8. 7 minus 5, I can do that. That's 2 because I have 7. I'm taking 5 away. I have 3. I need to take 8 away. Can't do it. So we're going to decompose. Leaves that with 1 in the 10,000s place. And then this becomes a 13 because we're adding 10 of those units to what we have. So 13 minus 8 is going to give me 5. 1, and I'm taking 6 away. I cannot do that. So again, we're going to decompose. This is great. I kind of like the way this is working out. So that leaves me with 0, but I have 10 units I'm adding to my 10,000s. So that means I have 11 10,000s. So 11 minus 6, that gets me 5. There's a comma. Boom. There is our difference. Okay. So I know it's a lot. And as I always say, we just keep practicing. You keep asking questions and you figure it out and you do your work. It's really important to continue to just practice, practice, practice. And always, like if you need to, use the model if it feels good, and then check with the algorithm or the other way around, right? Like try the algorithm. And if you're not sure, then go model it because you feel comfortable with modeling, and then you can compare your answers. So as always, I really thank you for your time. We'll see you the next video, and keep up the great work.